In this video, we will be looking at the exercise work on set theorem. And if you are new to this channel, consider subscribing and also hitting the like button. And if you haven't yet watched my other videos where I taught set theorem, please consider watching those other videos so that you'll be able to understand just how to go about these questions. So the question is saying, given that U, which is the universal set, is this particular set which has been given there, then we have been told that X is a set of even numbers in U, and Y is a set of prime numbers in U, and Z, of course, is a set of integers. Then we have been told to perform those set operations. So I'm going to start with the first one. The first one is saying we perform X union Y. Now, the set X is a set of even numbers. So even numbers are numbers that are divisible by 2. So we have -2, we have 2, we have 4, we have 6. These are even numbers. Then we come to prime numbers. These are numbers which are not divisible by which are divisible by 1 and itself. So of course we know that we are going to start from 2, then of course we have 3, then we have 5, then of course we have 7, only divisible by 1 and itself. Alright, so we can now perform the set operation X union Y. So X union Y is going to be, so we are going to start from -2. Okay, so this is going to be -2. Then we are going to have 2. Then we have 3. Then 4, 5, 6, 7. Okay, so this happens to be our X union Y. All right, let's perform the second set operation. So the second one is saying we find X intersection Y complement. So the first thing that we're going to do is this. We're going to find the intersection of X and Y. So where is X and Y intersecting? Okay, now notice that in X we have 2, we also have 2. Okay, so they are intersecting at some point 2. So the first thing to do is this. So we're going to say, we work out what is in the brackets. So X intersection Y is equal to 2. So complement simply means we are going to get whatever is, we are going to get whatsoever is in the union set, but we just remove 2. Okay, so we exclude 2 from the union set. Okay, let me show you what I'm trying to say. So this is what I'm trying to say. Okay, so here we have 2, here we have 2. So all the numbers that are going to remain except 2 is the final answer. So in this case, our X intersection Y complement is all the members in the union set except 2. Okay, so we have -2, we have -1, we have some 0, we have 1, we have 3, we have 4, we have 5, we have 6, we have 7, and this happens to be our final answer. Okay, let's try to find the third question, which is saying X intersection Y / Z. Now, if you follow my tutorials, you understand what this means. And of course, it's a very simple question. Now look at this. The first thing to do is to work out what is in the brackets. Now, set Y is a set of prime numbers. Let's just try to list it again. We have 2, we have 3, we have 5, we have 7. Set Z is okay. Now look at this. So Z is this particular set. So we have -2, we have 3, we have 5, we have 6, like that. Now look at this. We have been told to find y/z. What does y/z mean? So y/z simply means all the members that are in y which are not in z. All the members in y which are not in z. So let's find those members. So all the members in y which are not in z. Okay, so 2 is not in y, 3 is in y, 5 is in y, 7 is not in y. Okay, then we have been told that it's actually x intersection y/z. So in other words, we find the intersection of x intersection 2, 7. So now which number is found in x also found in y/z? Of course, our final answer to this particular set operation is going to be 2. So this is just how simple everything is. Let me just try to wrap the board. Okay, so make sure that you subscribe to the channel so that you may be able to learn so many tutorials. Now look at this. The fourth one is saying we find the cardinality of x union y. Okay, so cardinality of x union y, cardinality is simply represented by n, then x union y. So the cardinality of x union y is simply all the numbers which are found in x union y. So let's count them. 1, 2, 3, 4, 5, 6, 7. And of course our final answer is simply a 7. Thank you so much.